2,4b. So we're still doing rate of change, just not just with polynomials anymore, harder stuff. Rate of change. All right, so for this entire lesson, the main thing that you need to know is to find the slope of the tangent, or to find the instantaneous rate of change. You need to use this formula every single time. Okay, and I'm going to look for your work on your homework, and I'm going to look for the work on the quiz next Tuesday and the test next Friday.
Test next Friday?
Yeah, where were you? We were just talking about. And then we're going to go ahead, and we need that formula for all of these, okay? So here we go. Let's do a tough one. Number 1. We are going to find the slope of the tangent. Slope of the tangent. By the way, slope of the tangent, instantaneous rate of change, all those things are exactly the same. Okay, at x equals 2, given this function, f of x equals 2 over x plus 3. Okay. Now these are going to get harder, I know. Yeah, it's not polynomials. We're not just foiling anymore. We're not cubing stuff. We're going to have some fractions. And fractions are tricky, so here we go. So we need to take the limit as h goes to 0 for f of x plus h. That's the first part in our formula right here, f of x plus h. So we're going to do 2 over, sorry, that's a 2. Try that again. 2 over, now instead of x, I'm plugging in x plus h into here. So I'm going to get x plus h plus 3 minus f of x all over h. All right. There you go. That's just the plug-in, okay? Are you good? You're okay with the plug-in? You're good? We plugged in x plus h into here, minus f of x all over h. Now, if you were to plug in 0 for h right now, you would get 0 over 0, which is bad. So what we're going to do is we need to do some algebra to get it to something that we can plug h at equals 0 into. So we need to get a common denominator in our numerator. Yeah, were you thinking that? Yeah? All right, so our common denominator up top is going to be, I'm going to need an x plus 3 times an x plus h plus 3. Okay, do you remember doing these in algebra too? Where you had to add these fraction things, you had to get a common denominator with them, and it's not easy. This is not easy algebra today. X plus h plus 3. All right, and this is all going to be over h still. So for this fraction right here, this one right here, to get this to be this with the common denominator, I would need to multiply top and bottom by, what's it missing from this one to this one? By x plus 3. Okay, so I multiply top and bottom by x plus 3, I get 2x plus 6. Over here on this one, I have 2 over x plus 3. It needs to equal this, so I'm going to multiply top and bottom of this one by x plus h plus 3, right? To get a common denominator. Do you see that, what I'm doing here? Top and bottom by x plus h plus 3. So I end up with 2x plus 2h plus 6. Okay, let's combine those into one fraction. So I have the limit as h goes to 0. When I combine this into one fraction, make sure that you are subtracting everything in the second fraction there. Okay, so I have a 2x minus 2x. Those are going to cancel out. I also have a 6 minus a 6. Those are also going to cancel out. What am I left with? A negative 2h. Good, I heard that. Someone even said negative 2h. I'm left with a negative 2h over x plus 3, x plus h plus 3. And all of this is over h. But instead of dividing by h, you know what I'm going to do? Yes. Yep. We're going to flip it and multiply by 1 over h. And finally, yes, these h's will reduce. That was giving me the problem when I plugged in 0. And so your last step now is to take the limit as h goes to 0 And when you do that, you get a -2 up top, and you get x plus 3 squared in the denominator.
Wait, what about the h?
So h goes to 0. I plug 0 in for h, and I end up getting an x plus 3 times an x plus 3, which is x plus 3 squared. Okay, what was that? What did I just find? Well, we're going to learn next chapter that I just found the derivative. Okay, that's what that is. I found a formula to give me the slope of the tangent line at any x value. Now, what was the x value I gave us way back when? X equals 2. So let's take 2 and plug it in. And so the slope when x is 2 is going to be -2 over 25? 25. -2 over 25. And that would be the slope of the tangent. Okay? All right. That would probably be part A. Wait. Yeah. We're good? Yeah. Okay. Part B would then be to find the tangent line equation. What's the tangent line equation there? Well, I need a point. I have almost an entire point. I only have half of a point. So to find out what the other part of my point is, I would go back up and do 2 over 2 plus 3, which is 2/5. Right? My original function is 2 over x plus 3. Okay? So to find the y value that goes with x is 2, you plug it in and you get 2/5. So the tangent line would then be y minus 2/5 equals -2 over 25 x minus 2. That's the tangent. Okay. The normal, they might ask you for the normal. It's exactly the same line equation in point slope form as the tangent, except that the slope has changed. So you use the same point, but the slope is now what? Opposite reciprocal. Very good. 25 over 2. And that would be the normal equation. Okay? It's hard, huh? Polynomials are nice and easy and fun. And they're nice and clean, but when you have something like this, it's tough. It's really not easy. All right. Let's do number 2. Here we go. So you're going to have a fraction. Now, let's talk about real quick just a line, okay? If I have f of x equals 3x plus 2, and I want to find the slope of the tangent at, say, x equals 5, okay? Don't go through the limit process on this. Don't waste your time. Because this is a line, and you know what line has? It has a constant slope. And so no matter what point you are on this line, the slope of the tangent will be the slope of the line. So if you do the limit process, you'll get it, but you're wasting your time, okay? The slope of the tangent would be 3 at any point.
Where'd you go 3?
Yeah.
The slope of the line.
Oh.
At any point. That 5 is arbitrary. Ooh, I used that word today. That's fun. There you go. If I told you to find the slope at x equals 1, slope of the tangent, what would the slope of the tangent be? 5. The slope of the tangent is going to be the slope of the line itself, because the line's constant, right? The thing about tangents is this. If I have a parabola doesn't have a constant slope. Down here, it's very slow. It's slow rising. But when you get up here, then it increases. On this side, it's negative. Okay? With a line, it doesn't change. So whatever the slope of the line is, will be the slope of the tangent. Okay, so knowing that, we're going to do number 3. Here we go. Now, find the slope of the tangent, or of the curve, or whatever you want to call it, of f of x equals the absolute value of x plus 3 at x equals 4. Find the slope of the tangent. F of x equals the absolute value of x plus 3 at x equals 4. Okay, you're not going to do the limit process on this one either. Yeah, this right here, the absolute value is just two lines put together, right? It's over a -3. It's this, and it's that. So at x equals 4, what's the slope of the line there? It's 1. M equals 1. It's just rise 1, run 1 for the whole time. Now if I asked you what is the slope at x equals -7, perfect. The slope would be -1. Because over here, this is part of the line is going at a -1. Okay? So lines are nice. Lines don't change at all. And even if you have an absolute value, those are just two lines put together. Okay, let's do one last problem, number 4. We're going to do an application problem. So it says here that a rock breaks loose from a tall cliff. I'm just going to say a rock falls with this position, S of t equals 16t squared. This is what the book says. All right, we are going to do a few things. Letter A, we're going to find the average speed of the rock over the first 2 seconds. Here he comes. Over the first 2 seconds. Okay. Find the average speed of the rock over the first 2 seconds. Now, remember, average speed is old school slope, okay? I was telling someone in AP Calc this because they were taking a test on something like this. Average speed. It's not instant speed, it's the average speed from 0 to 2 seconds. So what you're going to do is this. You're going to find 2 points. You're going to find the point when x is 0, and then you're going to find the point when x is 2. So over the first 2 seconds would be from 0 to 2, that interval. It's almost like they gave you this, like the ones in the book last night, 0 to 2, okay? So when you plug 0 in, you get 0. And then when you plug 2 in, you get, what is that, 48? 64. 64, yeah. 64, okay? And so we find the average rate of change of this rock. We do 64 minus 0 over 2 minus 0, and we get 32, and this is in feet per second. I should have told you that. Feet per second. Feet per second. There you go. 32 feet per second. Okay, now let's go ahead and part B, find the instant speed or instant velocity, whatever you want to call it. I'll just call it speed. The instantaneous speed at t equals 2. Okay, so this is the average speed from 0 to 2, but exactly at 2, how fast is this rock traveling? Anytime you have instant speed at a specific time, at one point, you have to do the limit. Okay? So here we go. The limit as h goes to 0. So we're going to do f of x plus h. So we'll do 16 times x plus h squared. You could use t instead of x if you want to, but it's fine if you don't. Minus f of x, 16x squared, all over h. All right, here we go. We're going to FOIL and distribute. So I get x squared times 16 is 16x squared. My middle term is 2xh times 16, which would be 32xh. And then my last term is h squared times 16, which is 16h squared. And this is minus 16x squared all over h. Okay, we do so many of these. I hope you get used to it. And then you go ahead and cancel those out. Factor an h to the front. that you're left with 32x plus 16h. All of this is still over h. Go ahead and reduce. And now here comes the part where people forget this part. This is the best part of all, though. You get to let h equal 0 now. Plug that in to there for 0 for h, and then you get 32x. Okay? So at exactly t or x equals 2, plug 2 in, you get 64 feet per second. So the average speed was 32 feet per second, but the instant speed at 2 itself was 64 feet per second. Pretty good?